Okay, so today's lab we're gonna continue to talk about the biochemistry testing. So let's do a review what we have did already. So we did, I'll say biochemical test 2. Okay, so what we did so far, we did 3 cube carbohydrate fermentation test. This is what we did already, okay? And we also did urea test. And then we did enzymatic testing. This is last week what we did. So what we have is, if you remember, we have those 3 agar plates and we split them onto 2, which is skim milk agar. And on one side you inoculate E. coli. The other side you inoculate Bacillus subtilis, and you should see a very clear transparent zone, or a huge transparent zone surrounding the Bacillus subtilis. So Bacillus subtilis is caseinase testing positive. Now the second agar is split blue agar. And this agar a little bit different. On the left side we inoculate E. coli. On the right side we inoculate Staphylococcus aureus. I don't think you can see it because it's been a little bit longer time, but I just want to tell you Staphylococcus aureus is lipase positive. And the last one is starch agar. And starch agar, on the left side, you inoculated E. coli. On the right side, you again inoculated the Bacillus subtilis. And I said we have to do a confirmation test, is you have to pour iodine. So which side is positive, which side is negative, depends on whether it turns brownish or not. And you could see clearly later on, Bacillus subtilis is amylase test positive. Okay, you can do a simple test by yourself. So this is what we finished so far. So we want to do 3 more testing today. We will talk about to finish the several biochemistry tests, then we're going to do more. First one, catalase test. And you already heard about in the lecture, catalase test. What is that? H2O2, hydrogen peroxide. If bacteria has catalase, it will break down H2O2, become oxygen and what? Water. And this oxygen is bubbling. So there is 2 methods you can do. Method number A is what we're going to do today. Is you have agar plates. This is nutrient agar. You split them onto 2 sides. Left side you inoculate E. coli. Right side you inoculate Staphylococcus aureus. Where is this one comes from? E. coli, I have a slant for you. Staphylococcus aureus, you're gonna get this from you last week split blue agar. You have a split blue agar. On one side you have SA, and you can inoculate onto a neutron agar. Then this agar will grow 35 degrees Celsius for 24 hours. And we're gonna drop H2O2 solution. If one side showing the bubbling, which means it is positive. If no bubble, it's negative. That's one method you can do. The second method what you can do is you can using a glass slide. And then you draw a circle. And you add bacteria there. And then you dumping H2O2. Also, you're going to see bubbling. If there's a bubbling comes out, it is catalyst test positive. Now, catalyst test is very important. We already mentioned in the lecture because Staphylococcus versus Streptococcus. Staphylococcus is catalyst test positive, Streptococcus is negative, which means one side is bubbling, the other side is not bubbling. This is what we talk about in the lecture. But there comes another question. Because catalyst test is widely used in a clinical microbiology area. So what is the major agar we will be using in the clinical area is blood agar. Is that right? Alpha hemolytic, beta hemolytic, gamma hemolytic. So we're going to use blood agar. Now, lots of the people, they will do on the blood agar, so you're going to do the same thing, then they dumping H2O2 solution to do the bubbling. Is that correct? No. So, you have always remember, catalyst test, never do on blood agar. This will give you false positive. Because blood agar already have oxygen there. Sometimes will be correct, sometimes will be wrong, because when you grow, the oxygen they used, it's you add H2O2, it's gonna start the bubbling, no matter what. So do not never do on blood agar. It's important. But lots of people doesn't know, because blood agar is a good clinical isolation agar. They try to do multiple tasks at the same time. But it can be failed. It can be give you false positive impression. Okay, so that's catalyst test. So today's work is easy. You get a neutron agar, you split them onto two, left side you inoculate E. coli from the slant, right side you inoculate Staphylococcus aureus from your own split blue agar. Then we won't have any trouble for the biosafety because it's from your own agar. Okay? So that's number 5. Number 4. Okay, number 5. We want to talk about the SIM test. SIM test. It's a semi-solid agar like that. And this time we will using needle. So let me show you. And I said very clearly all the time, lots of people will make a mistake. This is needle. There is no loop. And this is loop because there is a circle. This is the only time in the lab we're going to use a needle. And what we do is pick the bacteria, go down right in the middle, took it out. Like stab, like you do a stab for agar. Okay, this is a 0.5% semi-solid agar. First thing. Okay, what are they tested for? This is using needle. 1 stab, 3 drops. That's I call the nickname. 1 stab, 3 drops. Now what are the 3 drops? What is this? Sulfide. Now, how do you know is sulfide tested positive? After incubation, 35 degrees Celsius, 24 hours, turn black. The reason is there is metallic ingredients such as iron in this agar. And once they reduce, sulfide becomes sulfide, they will be showing black color. But the black color will be gone because finally it will be reduced back. Okay, so it turns black. What is I means? This is Indo. Okay, this guy we're gonna talk. This is Indo. You heard about Indo. What is Indo? Okay. I'm gonna go here. This. Okay. Here, here, here. CH2, H, COOH, NH2, sorry, that's NH2, that's H. What is this guy? Tryptophan. And the tryptophan, there is a subunit there. This is Indo. So if bacteria using tryptophan, they will generate the byproducts is Indo. So that is tryptophan, byproduct. Now how do we know Indo positive? You need to pour a couple of drops of a special reagent on the top after incubation. That one called, I use a red color. That is called a reagent Kovac. This needs to be poured there. If you show cherry red color, it is Indo positive. And I tell you, Indo test is very important. There is one bacteria everybody knows it is Indo positive. E. coli. E. coli, Indo positive. Okay, so that's a very interesting stuff. Okay, what is the M means? I don't have any space. M. This means motility. Now, how do we test the motility? You put it down, take it out. If the bacteria stay right in the middle, no motility. If the bacteria goes everywhere, it becomes motility positive. Okay, which bacteria is motility positive? Have a strong moving capability. In the class we talk about Proteasa vulgaris. However, it is a biosafety level 2 pathogen. We're not going to do that. Instead of we using a surrogate bacteria, it's called Citrobacter. We did already. Okay? So that's the second one, last one, motility. Now motility related to what? Flagella. So that's what you in your class you learned. Okay, the monotrichos, is that right? Then amphitrichos, then Lophotrichos, and last one, peritrichos, petritrichos. So that's something you need to know in the lecture, you also have to know. It's important. Okay. Last test today, deaminase test. Okay, deaminase test, we're using a slants. This slants looks easy. So you inoculate the bacteria, let it grow 35 degrees Celsius, 24 hours. Okay, what is that then? What's the story? This is a very special slant. It's not a slant that looks similar, but the ingredients is different. What is it? What is this one called? This is called phenylalanine deaminase test. Okay, what is phenylalanine? You don't know about that. Okay, let's do it. Do you know alanine? You should know. Is that right? Okay, go back to structure. CH3, go C, then go H. You have NH2, so you have COOH. Amino group, carboxy group, H and CH3. That's alanine. Everybody knows. Okay, what means a phenylalanine? That's obvious. This guy is gone, becomes H2. H3 becomes H2. So you're going to add what? Add a phenyl group. Is that right? That's called a phenylalanine, which is like this. So that's phenylalanine. It's not difficult. And what means deaminase? This guy is gone. And then the left one will be this whole circle. Okay, what is this one called? We haven't talked about that, but you maybe know. This is a phenylpyruvic acid or phenylpyruvate acid, VATE. Okay. Pyruvic acids. Now, why I use green color? Because once you inoculate, we're gonna dump in, gonna add ferric chloride. If this one showing you dark green color, it is phenylalanine deaminase test positive. So, we have only 3 tests today. But the story behind that is a lot of the chemistry there. Related to the indole, the byproducts of tryptophan, and the deaminase phenylalanine test. Okay? So, that's what we have. Now, let's assign the culture. Catalase test. You guys all got to do the same, everybody. Left side E. coli, right side Staphylococcus aureus. SIM test, we are going to do you assign the culture. Phenylalanine test also going to be doing you assign the culture, okay? So, start from here. We can separate them onto everybody will be here is E. coli, Citrobacter, Bacillus. So E. coli, Citrobacter, Bacillus. E. coli, Citrobacter, Bacillus. E. coli, Citrobacter, Bacillus. E. coli, Citrobacter, Bacillus. Then E. coli, Citrobacter, Bacillus. E. coli, Citrobacter, Bacillus. E. coli, Citrobacter, Bacillus. E. coli, Citrobacter, Bacillus. E. coli, Citrobacter. That's what you're going to assign to do SIM test and phenylalanine deaminase test. Okay, now, again, everybody come in here. We're going to show you how to do it. Okay, same thing. I need to show you because it's lots of stuff there. It's going to confuse you. Citrobacter. You have the Bacillus, let's say. You have Bacillus citrobacter okay, right here. All right. So, okay, what are we going to do? You can choose to using loop, or you go ahead to using using a plastic loop or metal loop, it's up to you. So I don't really force you to choose one, okay? Let's do something easy. Let's show you the important one first. SIM tester, okay? SIM tester. First thing you're gonna label. So you don't have to emphasize it. You bench number, you name the bacteria you inoculated. What you're gonna do, I'll just show you a demonstration. I'm not gonna turn on the fire. Turn on the fire, you have to flame it. Okay. Then coming from, this is your azion culture, let's say. Pick the azion culture. Then you go inside. Make sure this is straight, okay? Straight forward down. Gently take it out. That's all. You don't have to do that. Because we want to see is a clearly motility happen. If you damage it, you're not going to see anything. So, very gentle. Flame, add it, touch the bacteria, very gentle. One more time. Very gentle right in the middle. Took it out. Because it's a semi-solid agar. It's not solid. If you do this, it's broken. Okay? That's the first one. Now, how are you going to do this guy? Same as you did it before. Split them into two. The left side, E. coli. Right side, Staphylococcus aureus. Where you get your Staphylococcus aureus? You have your own split blue agar. Pick from SA side. We don't have to worry about contamination because I give you a new strain that could cause another cross contamination. That is your own place. So you pick it from there and using loop to do the stream. The same like you did for this guy. Don't forget label. You name, bench number, bacteria, date. Okay, what's the last one? Phenylalanine deaminase test. This is easy. Use a loop, inoculate the bacteria to do zigzag streak. Okay, like we did before. So just demonstrate to you briefly. Okay, any questions are clear? And on Thursday, don't forget, it's not done. On Thursday, we have to do confirmation test, which is you add H2O2, you add a Kovac, and we're going to add a ferric chloride to confirm it is positive. So today is inoculation, is a preparation. On Thursday is a confirmation test. That's the reason we cannot do 5 or 6 at a time. Because otherwise you have another set that is a totally mess. That's why we cut down to 2, 3, 3 each time. Okay? Go ahead to do it.